Okay, in this video, let's go ahead and look at the DT and the VT graphs. If you're a Monday, Wednesday student, we're going to go ahead and push this back and do on not Wednesday, but on Thursday, okay? Thursday is when it's due. So if I haven't made an announcement yet, which I thought I did on Teams, I'll go ahead and make sure to do that tonight as well as on Blackboard. But let's go ahead and get through this. I think this is an amazing worksheet, and by the time we get through with this, it's going to be like magic, I'm telling you. But I know that I gave you some color pencils in the beginning of the school year, so please get those color pencils out. Yes, it must be color coded, and yes, you need to match the colors that I give you. I got you color pencils, so I'm expecting you to use it. So when you do turn it in, it's expected to be color coded, okay? Coloring it has a lot to do with the magic behind this, okay? So here's what we need to do. We need to get some colors out. First thing is we need the red, we need the green, we need blue. Let's go ahead and we've used orange, and we've also used black. Those are the 5 colors we're going to go with, okay? I'm going to go ahead and have a pen with me too, so that way I can write with. So let's go ahead and get through this part. First thing is, look up here. We're going to do the DT graph first. So go ahead and find your worksheet that says distance versus time graph. That's the one we're going to work with first. On this one, we're going to make 4 little DT graphs on the side. Okay, so over here, 1, 2, 3, 4. And this is a distance on the y-axis and a t for time on the x. DT, DT. And if you watch the videos over the notes, then you heard me say that a DT graph tells me the speed of the object. Now, the first DT graph that we're going to talk about or discuss is going to be when that object is at rest or came to a stop. Okay, it stopped moving. The second DT graph is going to be a graph where we have a constant speed. Okay, my object's moving at a constant speed. That's when it has cruise control on. Our third DT graph is going to be when it speeds up. That means you're hitting the gas pedal and you're accelerating, going faster and faster. The fourth DT graph is going to be when you slow down. You let off the gas, it slows down. You hit the brake, you slow down even more. You start driving or rolling over friction, it starts to slow down that object. So those are the 4 parts of a DT graph. So if it's a DT graph, it can look like one of these 4 things that are happening. Okay, so let's go ahead and go with the first one. The first one's green. If it's a DT graph and you need to look at the y and x axis, sometimes it might say position or location. That's the same thing as distance or displacement. But if it's at rest, with your green matte pencil, draw a line. It's going to be a horizontal line with no slope. Now, this is a distance on the y-axis, and this right here is my 0, 0 point. The further away from the origin or from home or from the start, the higher up my horizontal line will be. The closer it is to the origin or from the 0 marker, the closer this horizontal line will be downwards. Okay? The next one's going to be a constant speed. So my object's traveling on cruise control. Now we've got 2 types of lines. One will be a direct relationship and the other one will be the inverse line. So a direct relationship, we said on the last unit, looks like this. And if it's a direct relationship, then that means that it is going away from the origin, away from home. If it looks like this, like an inverse relationship graph, then that means that my object is moving back to the origin. It's moving back towards home. Okay? The next one is going to be speeding up. If it's a DT graph, my object's going to start to look like this. It's going to have that curved slope to it right there. And if it's slowing down, then it is going to look like this. It's going to start making that kind of like a mountain, a hill slope. Okay, so those are the 4 that we need to recognize. Make sure you're using your colors. That's part of the grading. Okay, that's part of the magic that we're about to do here. So those are the 4 types or the 4 parts of a DT graph. Again, you have to read the X and Y axis. Now with those colors, we're going to go back to start off with green. Anytime on the words over here that you see the word stop or rest, we're going to go ahead and box it in green. For an example, number 1, at rest, parentheses, stopped. The entire time. Number 2, constant speed and then suddenly stops. Gradually slows down but does not stop. Don't color that one. Slows down, look at this, stops, then speeds up. Constant speed and then speeds up. Speeds up the entire time. Constant speed that is not 0. Moves towards the reference point or origin, then stops. Gradually slows down to a stop. Constant speed and then gradually slows down. It didn't say it stopped, it just said that it slowed down, so don't mark that one. Speeds up and then suddenly comes to a stop. Okay, that's my green. Now let's go ahead and go with our blue. Anytime we see the words constant speed, whether it's moving away from the origin or back to, we're going to box it in blue. So let's go ahead and start from number 1. Nope. 2, yes, constant speed and then suddenly stops. 3, gradually slows down, then does, nope. Number 4, slows down, stops, and then speeds up. Nope. I want a constant speed like this on number 5. Number 6, speeds up. That's not constant. That's not cruise control. Number 7, constant speed that is not 0. Number 8, no. Number 9, no. Number 10, yes. Number 11, speeds up then suddenly stops. No. Number 12, multiple constant speeds. Not only is it constant speed, but it's multiple. So that's going to be multiple lines. Not only that, that increase in value. Okay, so we'll see that definitely in a little bit. Let's move the blue out of the way and let's go to our third one, which is red. Anytime we see the word speeding up, or what's another word other than speeding up? You're hitting the gas pedal, you're going to accelerate. Okay, so let's look at number 1. No. Number 2. No. Number 3, gradually slows down. Nope, I want to speed up. 4, slow down, stop, and then, here it is, oops, speeds up. Number 5, constant speed and then speeds up. Number 6, speeds up, parentheses, accelerates the entire time. Number 7, no. Number 8, no. It says moves towards number 8. Let me go back real quick. Moves towards a reference point or origin. It says that you're moving. It doesn't say that I'm speeding up. It doesn't say I'm slowing down. It says that I'm just moving. So looks like this one is going to be a blue. So let's go ahead and make that one in blue. Something's fishy here. It doesn't say speed up or slow down. It says moving. So I'm going to just underline that one right now in blue. Let's keep going. Number 9, no. 10, no. 11, speeds up, yes. And no on 12. Let's go look at our fourth one. Our fourth graph is a slow down. Okay? So anything that says slow down, decelerate. Number 1, no. Number 2, no. Number 3, gradually slows down but does not come to a stop. Number 4, slows down, stops, and speeds up. Number 5. Number 6, no. Number 7, no. Number 8, no. Look at this, 9, gradually slows down. 10, constant speed, and then it's going to slow down. Number 11, no. And number 12, no. Okay, so we have everything boxed in. I'm telling you, this is a really good skill to learn how to do, because if any one of you plan to do anything in some kind of engineering or construction, and you may not even think that that's what you want to do. It might be something later on. This worksheet is going to be gold later on in the future for you, okay? If you plan to do something else later on, that may have some science classes, this may still be amazing for you, okay? So it's a really good worksheet to keep. Now I'm going to move the orange out of the way. I'm going to go back to the beginning. Our first graph again was green. Now that we did all the words, let's go ahead and let's color in all of the graphs. Once we finish this, the magic's going to happen. You're going to see it and you're going to be like, what? It's going to be awesome. Now let's look at this graph number 1. It has no slope. It's a straight flat line over here. Now this straight flat line is what we're going to box in down here. Anything that has a flat line. Now let me show you, because some of them are really hard and difficult to see. Letter A, no. B, oh, we can see that. Look at that's easy. C, right here at the end, on the tip of C. D, you see right here where it flattens out for a little bit? Next one, E, yes. F, no. H, no. K, no. L, no. M, no. N and O. Okay. Let's go back to the next color. Our second graph was blue. So any kind of direct or inverse relationship graphs are going to be blue. So let's go back with our pencil, and it has to be a nice smooth slope. That's no, that's a curve. Curve. E, yes. F, not only is it F, but look, it's F at 2 of them. H, it is till this point, and then it starts to curve. K, it is to about here, and then it starts to curve over here. L, the whole time. Oops, sorry. M, no. N, no. O is a no. Okay. Well, let's go back to graph 3, which is in red. So let's get your red back. Any kind of curve swoop line like that is going to be red. A is a no. C, no. Look at right here. D. E, no. F, no. H, yes. K, no. K looks like the mountain hill type. M, yes. N, yes. And then O is already done. Now the last one is orange, and it's going to be when it slows down. It's going to look like that hill curve mountaintop. Okay, let's go ahead and get that one. That's letter A, C, D, K, and that looks like it's it. Now I'm going to move my colors out of the way. I'm going to get back to my pen, and here's where the magic comes in. I'm telling you, it's like mind-blowing. Let's go ahead and let's look at number 1, because it tells me in the direction that we need to match the words up here, the statements 1 through 12, with the correct graph that correlates with it. And I like to simplify your life in physics. I promise you, if you're scared of this class and you think it's difficult, I know I told you it was, but if I'm telling you, if you follow my steps, I'm going to simplify your life. Look at this. Number 1, the only color that I colored in on number 1 was green. Green only. Can you find a graph over here that has green only? Oh, those two match up. Look how I'm color coding your life. This is awesome. Let's look at number 4. I'm skipping. Orange, green, and red. What graph has those same 3 colors in that order? Orange, green, red. That's the only one. D. If you don't Believe me, let's look at 7 for an example. Blue only. Which one is blue only? And look, not only that, there's only one blue. Constant speed, that's non-zero the entire time. L. Not bad. Now let's go ahead and let's start back from the top and let's finish them up. I want to finish all of them with you. Number 2, blue and green. Which ones are blue and green? I actually see 2, B and E. We're going to come back to that because those 2 are, they're both blue and then green in the same order. 3, orange only, A. We did 4. 5, blue and red. In that order, blue and red, H. 6, red only, M. Red only. I mean, look, this is magic. Literally, this is crazy how awesome it is. Number 8, blue and green, blue and green, blue and green, blue and green. I'm going to walk away from that. I'll come back. 9, orange and green. Only orange and green here is letter C for 9. That matches. Blue and orange. K. Blue and orange. 11, red and green. Red and green. That's the only one that matches. That's all. It can only be that one. And then the last one. Look at this. I underlined it. Multiple constant speeds. So multiple means more than one. More than one blue box. Which one has more than one blue box? Only this one. Letter F. Now, I left those 2, number 2 and number 8, alone. And the reason why is because I told this to the other classes. Let me make sure I video this so that way if you missed the lesson or you didn't pay attention during that time, you can hear it now. In physics, even the smartest of the smartest kids that I have every year makes the mistake. And this mistake is it. They start to assume things. When you read our word problems in physics, please don't just assume. Don't assume. Now, I can tell you that there's a couple of assumptions you can make in my class or in physics in general. Number 1 assumption that you can make, unless the word problem says anything about you or that object is on another planet or in outer space or on a different galaxy, okay? Unless this is like some Miss Frizzle kind of thing, we're going to always assume that we're on planet Earth. That my object, if it's falling on planet or Earth. If it's just sitting there, it's sitting on planet Earth. If it's rolling on planet Earth. Okay? If it's another location than Earth, they will tell you. So that's one assumption that we can assume in physics. The other assumption in physics, I'm going to go back to your chemistry class that you had, and I'm sure that you had an awesome chemistry teacher. Your chemistry teacher probably talked about the laws of thermodynamics. And within the laws of thermodynamics, one of them is called entropy. Entropy is about disorder and chaos in the universe. And let me go ahead and give you an example. My youngest kid, she is 8 years old. She just had a birthday very recently. She's 8 years old. So next year, she's going to turn 9. She's turning 9 years old. There's nothing I can do. I can squeeze her. I can hold her tight. I can tell her to wear the same 8-year-old clothes if I want. Whatever it is, I can continue to fix her hair the same way. No matter what I do, she's going to turn 9 because she's going to grow. She's going to start, let's look at this graph. She's going to start from 0 point and she's going to go forward and she's going to move away from the origin. Does that make sense? For an example, your birthday, let's just say you're 16 years old. And so the next birthday, you're going to turn 17. And no matter how much your parents love you and want to keep you a little kid, the next birthday, they want you to be 7, not 17. But no matter what we can do, we can't have you go backwards. We can't have you stay at that cute 7-year-old phase. You're going to turn 17. And then eventually you're going to turn 27 and 37 and 47. Does this make sense? Where entropy, things naturally in this galaxy universe that we live in, planet Earth, naturally go into what we call chaos or disorder, or listen to this, away from the origin. Away. So another assumption in physics that we can assume is that things are naturally going to move away from the origin. Okay? Unless it tells you it is moving back towards the origin. Okay? So let's go ahead and let's look at this again. Constant speed then suddenly stops. Does it say it's going away from the origin or back to the origin? It doesn't tell you. So what can I assume? That it's moving how? Away from the origin. Let's look at this blue and this blue. This one is moving away from the origin. Now I'm going to make that assumption because there's only two assumptions really that we can make in physics. And those are like the only two that I can assume. Everything else, when you start assuming in my class, you're going to start making mistakes. Okay? Now let's go ahead and let's look at the other one. Number 8. It moves towards, how does it move? The reference point, or it's moving backwards towards the origin. It actually told me on this one how it's moving back towards the origin, and then it stops. The only one that goes back towards the origin is B and not E. Okay, so that's every single year I make sure I stop here because that's a really two good questions, and it lets me go and tie into our assumptions in physics. Okay, that entropy is going to happen and occur no matter what, and we try to decrease the entropy, but entropy, which is chaos and disorder, is just going to naturally occur, and it naturally occurs away from the origin. So let's go ahead. The correct answer for 2 is E, and the correct answer for 8 is B. Again, if you kind of get stopped on a question, look at this. We were able to answer everything else except for those two. Just go back to those two and then answer those then if that's the case. Okay? But again, you can make two assumptions only. Now let's go ahead and move this out of the way. This is completely done. You need to submit this by Thursday to get your grade. But there's another worksheet. This worksheet over here is what we call a VT graph. A VT graph, hint, hint, for quiz/test, tells you the acceleration of the object. Okay? Now on VT graphs, there are 5 different things that a VT graph can do. So let's go ahead and let's get a Y and X axis. This is number 1, a YX, number 2, a YX 3, a YX 4, a YX, which is 5. And all of them are going to be VTs, VTs. And one more time, a VT graph is going to tell me the acceleration of the object. Now the first VT graph over here that we're going to look at, number 1, is going to be at rest/stop. When my object stops and comes to a rest, the next one, it's going to be moving away from origin at a constant speed. Okay? On cruise control. Away from the origin at constant speed. Number 3, towards the origin at constant speed. The next one, number 4, is acceleration. My object is accelerating. It's hitting the gas pedal. The next one, it's decelerating and it's going to slow down. There we go. So those are the 5 things that a VT graph can do. Now let's go ahead and go back since we have our graphs here, and let's go ahead and start from the first one. And I'm going to go ahead and start at green. On a VT graph, if it is at rest, it's going to be a horizontal line with no slope at all. But, here's the but it is going to be, and I don't care how far away from the origin or how much is coming back towards the origin, I don't care. If it stopped and there is absolutely no motion going on, then the line will always be on the x-axis. The horizontal, no slope line will always be on the x-axis. If it's a VT graph, and on my VT graph, it is going to move away from the origin at a constant speed, like cruise control, right? It is going to be a horizontal flat line with no slope. Depending on how far away from the origin is the x-axis. The further away, the higher up away from the x-axis it's going to be. The closer towards the origin, because it only moved away a little bit, the closer down here towards the x-axis. But this flat horizontal line will be above the x-axis. Okay? Always above. Number 3. If it is going, I'm going to use red here. If it is moving towards the origin at a constant speed, it is going to be a flat horizontal line again with no slope, but it's going to be below the x-axis. Now, if it's moving towards the origin, the closer it gets to the origin, the closer this line is to the x-axis. The further away it is from the origin, the further away from the x-axis it's going to be. But it will have no slope. Let's go to the next color. I'm going to use orange. If it is accelerating, it is going to have a direct relationship line. It is going to move, and it's going to look like that. If it is decelerating, I'm going to black, then it's going to be an inverse line, and it's going to look and move downwards like this. Okay? So those are the 5 things that a VT graph can do. Now we're going to go ahead and do the same exact thing, and we're going to get the same kind of magic for a VT graph, because again, I want to make your life simple in physics, okay? Let's start off at number 1. Every single time you see the word rest or stop, we're going to box it in the words, okay? So let's go ahead. Number 1, rest. Number 2, suddenly stops. Number 3, no. Number 4, yes. Number 5, no. Number 6, no. Number 7, no. Number 8, then stops. Number 9, stops. Number 10, no. Number 11, suddenly stops. Number 12, no. Okay, move that out the way. Let's go to blue. Blue is going to be away from the origin at a constant speed. One more time. How can we assume? There's 2 things we can assume. One of them is that we're always on planet Earth, unless we're told that somebody got onto the magic school bus and now they're in Mars. Until then we're going to assume we're on Earth. The other assumption is that due to the laws of thermodynamics, entropy is always occurring, meaning that things are always moving away from the origin. It's moving away from where it started off originally. Okay? So we're looking for the words constant speed, okay? But particularly away from the origin. If it says towards the origin, then it's going to be red right away. If it doesn't say towards the origin, what color is it going to be? Blue. Okay? So let's go ahead and let's look. It says constant speed. Does it say towards the origin? If not, we're going to assume entropy is occurring, and it's going to be blue. Okay? I'm going to have my red with me just in case. Number 3, no. Number 4, no, no, no. Number 5, constant speed. Does it say towards the origin? No. So we're going to assume that entropy is occurring here, right? Disorder, chaos, away from the origin. Number 6, no. Number 7, constant speed. That is not 0. I'm going to go ahead and call it a blue. Moves toward, uh-oh, there goes that word, towards the reference point or origin. Now, they didn't use the word constant speed, but they also didn't say accelerating or decelerating. Okay? So I'm going to call this one red. Gradually slows, where am I at? 9, no. 10, look at this, constant speed. 11, no. 12, multiple constant speeds that increase in value. But here's the key word, multiple. Okay. It looks like I did the red and the blue, so I'm going to move those out of the way, both of them. I'm going to go to accelerating, which is orange. Anything that says speeding up or accelerating. So let's go ahead and do that. Oh, whoa. 3. No, not 3. 3 says slows down. 3 is black. I'm so sorry. You're probably thinking that right now. Like, stop. So thank goodness this is a color pencil, right? Because you can truly erase it if you need to. But there it is in black. Then orange, let's see, 5, yes. 6 is a yes. 7, no. 8, 9, 10. 11 is a yes. And 12. The last part is going to be when it slows down. And it slows down at 3. I see it slowing down at 4. It slows down at 9. It slows down here on 10. And that's all I see. Now I'm going to stop here. You are to do the same thing, and you're going to color code those graphs down here. Then you're going to match them. This is where I'm going to pause, and I need you to practice on your own. Okay, are you going to see words and graphs to match them up on the quiz and test? I guarantee you are. Okay, and this is going to be part of our lab for next week. Alrighty, so make sure that you know that this is going to be there. It's part of our lives, and there's a good chance that you may see this again later on, and this is an amazing worksheet to keep and hold on to. Okay, so let me go ahead and move that out the way. This is not going to be due on Wednesday. It's going to be due on Thursday. I think I've already made an announcement on Teams. I'll make an announcement on Blackboard, and I will post this video for everyone to look at. Okay, have a great day. Bye-bye.